My name is Olcay. For those who don't know me, I'm the program manager of HyperStudy department, and today we will present the new features and enhancements coming in the 2022.0. So today I'm planning to cover the enhancements in the following categories: data extraction and visualization, reports, customization, and documentation. But as always, first and foremost, I'd like to take a moment to thank our development team for their dedication and hard work, and the field specialists for their valuable feedbacks, which is one of the major driving factors toward the betterment of the product. Okay, so let's start with the data extraction and visualization. The first topic is importing variables per model. So each model individually can be invoked to extract variable information. You can call it like localized task of import variables. Why we need it? Imagine you have more than a study with more than one a model type. An example here, optics and radius. So you import the variables and you modify the attributes of the second model here, and then you might want to introduce a new a resource file for the first model, modify the Beam FEM file. When you do global import variables, all the attributes or changes made in that model 2 for the variables will be lost. So in order to prevent that, we introduced a local import variable option. I'm just going to go to the HyperStudy to demo the feature. So when you have two models like that, you modify the let's say a lower bound of a variable coming from the second model. Okay. Prior to this release, if you do import variables, which is the global behavior, when you go back, see it's defaulting back to its original lower bound. But with this local option, I don't need to import variables from an entire the study. I can just do localize input variable if I want to introduce a new, for example, resource file for the optics drag model type here. See, the modification is there; it's not lost or overridden. Go back to my study. Okay. So we covered that one. The second one is probably the highlight of this release. We introduced the image support in HyperStudy. Similar to data sources, one can define the media sources through which the images of a solver process can be read and post-processed later in the media tab. So each images from each simulation result is associated with their respective run folder. Again, I'll demo this quickly. I have two models to demo here. One from the structural side, the Hyper-V model. I'm going to be using the Hyper-V model. By the way, so for those who are familiar with the Hyper-V model, we introduced a minus image solver input argument, which is going to output a screenshot for each hotspot, for each page. So when you have multiple windows representing multiple hotspot results, for each window we're gonna spit out the images. And if I go to output response area, so we have this media sources, a new tab introduced. By default it's hidden, so in order to activate it you have to go to the tab options and click on it, or you can just right click in this area and activate the media sources. So we have two options. You can manually add the images into the media sources area. Like here I can go to the respective run folder and I can pick the images one by one. And the other option is we have this find media option, which scans the run folder and finds all the the images available in the after the solver process. And later down the process, when you go to post-processing area, we have a new media tab. So in here, when I click on, when I, shuffle through the runs, you see the images of from the respective folders are being, read here, and you can do some comparisons. You can, create animations. Just get rid of this so I can play the animation. I can see the change like from run to run. Can stop that one. So for each run, if you have multiple images in a single run, you can, go through the images one by one. And currently we have, out of the box HyperView, and the Flux Motor supports that, option to have images. If I go to Flux Model, and here I have the one optimization like study here, and similar to what I've done with HyperView, I can pick all the runs. Oops, sorry, I didn't add the images yet. So Flux Motor, spits out a number of images in each run folder. I can pick all of them, or I can just just use the useful ones. For example, I can just single out this 11 image, which is going to be probably more useful in this case. I can go back to my table, play the animation, and I can see the change in the, for example, the magnet area. Or I can stop this one. I can pick, for example, the initial design and the optimum design here. Oops, sorry. Here I can do comparisons between the two runs. This was my start point, and this is my optimum run. So with this new feature, you can do visual inspection or visual study of your designs, whether it's geometric change, or whether you look at the stress or displacement fields, and etc. Okay, and another thing, before I forget, I can also make comparisons between the two models. Not to get out of the multiple window option, so I can look at the differences between two iterations. So I can clearly see that the changes happening at the end of each magnet. So instead of having a vertical 90 degree, the angle, so it's kind of sloped here. Okay, going back to my presentation. If you guys remember, we introduced, or if you ever used it in the previous release, we introduced the show best design option to mark optimum run in a scatter plot. In this release, we took it to a further step, and we added a tolerance option, which help you visualize alternative optimum design points on top of the best one. So the user specified tolerance here, you can see from the image. It's a relative distance between the objective value of the best point and each alternative design. And this is also implemented for, the show best design option was only available in scatterplot. Now we extend it over to parallel coordinates. I go back to HyperStudy environment. I'm going to go load the study. Here you go. So here's my scatter plot, and we have this show best point option. As you see here, it's we accentuate the best run in the scatter plot, and now we have this new best tolerance option. So when we increase that, we eventually going to see more, points are being accentuated. So basically, it's similar to what we call it Pareto front. Depending on your tolerance, you can see multiple design options as opposed to the best one. And this is also extended over to parallel coordinates. show a best point, and it will just sort of dim out the other runs and single out the best point here. You can see the best swim lane, and when I increase the tolerance, and more swim lanes are popping up in the parallel coordinates. Okay, going back to my presentation. Okay, constraint markers in parallel coordinates. So we introduced an optional a visual tool in parallel coordinates for responses with constraint definition. So we mark it in a way that like when you look at the swim lanes and it's going to help you like enhance the the post processing experience when you look at the swim lanes, and you'll see what's the territory of like violation, and you can easily differentiate the violated runs from the feasible runs. Then going back to HyperStudy, I'll just get rid of this last point and activate the show constraint option here. So you see we have one constraint here for the volume, and I can see that some of the lanes are going through the domain of or the territory of a violation. Another area we had some enhancement is the reports. In reports, we introduced Altair binary format. I'm sure like some of you are already familiar with that, what it is. So basically, you can we allow exporting HyperStudy table data in an ABF format, and it is available in study, both in study and approach level. And with this option, one can take the data to platforms like Hypergraph or similar, whichever can read ABF files and create custom visualizations. Let me just load the demo model. Okay, here. So in the report area, so we added this Altair binary format option. You can create a report, and go into the report area to respective approach name. You'll see an ABF formatted output file, which contains the summary, and depending on the approach or study you're dealing with or exploration, it will have different type of tables in there. And another option is we can create this ABF file from the file export option, and we have this new Altair binary format option here. So this is going to create an ABF file containing all the data from each approach. So if I have to go to Hypergraph here to demo it, report. So if I load the study level one, I can we represent approaches as subcases in this the environment. So I have two options here: sampling, fit, and optimization, for example. So for optimization, I can take summary table, and one of my axes can be diameter. The other one can be height here, for example. Oops, let me just pick the plot. Okay. Yeah. So let me just turn it into a scatter plot quickly. And there we go. So I can take the data from HyperStudy in ABF format and bring it over to Hypergraph and make my own custom visualization options. Okay. Another option added in the report area is a functional mockup unit. Those who are not familiar with functional mockup interface. It is a standard used for exchanging simulation models between platforms. So similar to Excel fit and the PyFit models, the HyperStudy fit models can be packaged in FMU format to be later used in different platforms. So if I go back to HyperStudy, load my model, I built my fit models for each response, and then when you go to report step, you'll see a functional mockup unit option here. And all you have to do is hit create report. In the respective report folder, you see an FMU formatted like a fit model. I will go to activate, which can load the functional mockup unit models. I'm going to read the FMU I just created, so I can see all the inputs and outputs, all this model information. Okay, so it will just give me all the inputs and outputs here on each side of the on both sides of the FMU block. I will create one signal generator, which is an input. I'm going to tie it to diameter, and I'm going to go read one of the responses with the display option here, area top. Okay, and let me just put something meaningful here, 50. Okay, and hit run, and it should give me the result for the area top option here. I can add another display, for example, material cost. I'm going to go ahead and run again. There we go. So this is the functional mockup unit option, and it requires 5 Altair units, by the way, and it doesn't require a library dependencies like PyFit, so you can take it, and run it from other platform operating systems without any HyperStudy installation. The other area we introduce enhancements is the customization. So in customizations, we have 2 areas where the development, efforts in. One of the user utility tool. So with the user utility tool, we extend the use of external or user utility tools to be used on selected data in post-processing area. Basically, I can go to summary table and I pick the data, and then with the run user utility option with a register like external function, I can do for example an external post-processing. Going back to my study summary area, for example, I can pick this like 4 columns here, 2 input variables, 2 results. And with this example, I'm going to mimic the scattered data using Plotly, and I'm going to introduce size and the color channels. So it's going to render everything in the web browser using Plotly library, but it's not limited to that one. Like it's really up to imagination and the use case. So if I bring that the Plotly example, so I render everything in the web browser, and I have the diameter and the height, and I can look at the the other 2 channels like area top and the area top bottom for the size option. And another area we had enhancement is the use leveraging HyperStudy's internal methods in the external Python processes. So for those who are already working with the external Python, algorithms. For example, you have an custom the optimization in hand, and you want to use, for example, a fit model inside. You can call the fast or any particular a fit model from HyperStudy and leverage in that external process. And yeah, so this is the enhancements we had for the for HyperStudy. But one last point is we also introduced a new tutorial for radios connection.